Hello, my name is Michael Da Silva, and this is my lab on light absorption. The problem statement is, how does color affect the amount of light absorbed by an object? Introduction to my lab. My lab is about how color affects light absorption. Long story short, white is a final product of mixing every single color together. So if every single color is already included in white, that means it doesn't need to absorb colored wavelength, which in other words would be energy. Black, on the other hand, is the starting point of all colors. All colors start in black. So therefore, for black to be the starting point, all colors need to absorb it to make it a solid, more defined color. For example, what happens if you add red to black? It would get dark red. So it's the same thing. Black absorbs any color / wavelength it could get around its atmosphere. My hypothesis is, I believe that color affects heat and light absorption. The darker colors absorb more heat because color is shown through wavelength. White is the most reflective and therefore less needed of any other colors since it's a mixture of all colors mixed together. While black, on the other hand, needs wavelength to make its color more defined, so actually have a color. It's basically a neutral that's looking for more. And since the law of conservation of energy states that energy cannot just disappear, energy is absorbed and leaks out of darker objects. That's why when some object has too much heat, it starts radiating heat. So the darkest color in this case will be blue, and I believe that blue will absorb the most energy out of all three colors. This is my material list. 4 beakers, 4 thermometers, 1 hot plate, food coloring of blue, green, and yellow, water as the control, tongues as to pick up the beakers once they're hot to put them on and off the hot plate, goggles, gloves, and a stopwatch, which we all pretty much are basic requirements to perform a lab. This is my procedure, the first out of the 2 pages. First, you would want to gather all the materials and safety wear that you'll need in order to perform the experiment safely and not burn yourself. Then you fill each beaker with 200 milliliters of water. Then add 10 drops of green food coloring to the water. Mix until the food coloring gets absorbed by the water and you can't see little streaks of color, but it's just one solid liquid. Then repeat all this for yellow and blue food color. Keep a beaker of water just for the control. Don't add any food coloring to it whatsoever. Once done, get the hot plate and find a plug that works. Trust me, this is important. I had to go around the room trying to find a plug that worked. But once you do that, put all the beakers on top of the hot plate and record its starting temperature. For example, just put it on there, let them all reach a neutral temperature after you put it in the water on top of the hot plate. Because depending where it was stored, it could have a different temperature than what the liquid is itself. So give it 5 to 10 minutes, that might even be way too much, to get to a neutral temperature. This is the second part of the procedure. Then you turn the hot plate on to number 5. Long story short, turn it about halfway. And then start recording your temperature, but make sure you have a stopwatch right when you start. Record every 5 minutes, and after 25 minutes, stop the project, clean up the beakers, and clean up your mess. But recording is definitely a major detail. You must not forget to record. Even if it's close to 1, do the highest temperature, because that could also make a difference, because it's on its way there. Even though it might be like a little centimeter hairline fraction away, do the highest temperature or the closest it's to. If it's a little higher than 50, then do 50. If it's a little higher than 31, do 31. Just make sure you get to the closest temperature possible that is shown, because since it's being heated up while you're recording, it will change fast. So you gotta fast when recording the data. As you can see, this is my data table for trial number 1. At 0 minutes, green, blue, and yellow all had a neutral temperature at 21 degrees, which was their starting point. Then after 5 minutes, green went to 30 degrees, while blue and control went to 29 degrees. Yellow stayed at 28 degrees Celsius. At minute 10, the color green was at 41, while blue took 43. And then yellow stayed at a temperature of 40 degrees Celsius, while the control got a little boost up to 45 degrees Celsius. On minute number 15, green got ahead by going to 55 degrees Celsius, while blue went to 54 degrees Celsius, yellow 53, and the control was also 54 degrees Celsius. On minute 20, green went up to 66, blue went up to 64, yellow is starting to slow down at 58, while control went to 66. On minute 25, the final marking period and recording of my data, the color green got 76 degrees Celsius, while blue got 75 degrees Celsius, and behind them, out of all of them, the lowest temperature so far would be yellow at 72 degrees Celsius, while the control went to 75 degrees Celsius. This is my graph, and it shows kind of constant line of regression, except as you can see right here, it goes, yellow is a triangle, it goes, then it does little swoop, and it stays behind after that. While every other color starts making its way up. Green kind of got slowed down right there, I don't know why, but control was the hottest for some reason, but that might have just been for some reason unknown. And then, as you can see, basically all the other colors stayed together, and green and blue were head to head or right next to each other, as you can see on minute 15 and minute 25. It makes a little house. Same thing with the control. It's in the center of all of them. So to sum it all up, in conclusion, the end of my experiment, my hypothesis, was not supported by my experiment, because blue was not in fact the color that absorbed the most heat, but in fact it was green that absorbed the most heat. This does prove my initial theory, though, that color does affect heat absorption, because as we look back on the data table, control did have a temperature difference between blue and green at some point, but in the final temperature, blue and control had the same temperature rating at 75 degrees Celsius. And yellow, which was the brightest color out of all of them, got the lowest temperature rating and lowest increase of temperature. As you can see right here, it's always on the bottom throughout the whole data, especially in the last two, where yellow stayed way behind. Since yellow is the brightest color, it did not absorb as much wavelength/energy that it needed, because it already had its own initial color it had. So therefore, it did not need to absorb any other color besides yellow wavelength. And this is the end of my presentation. Hope you enjoyed it.